Recently, I had an opportunity to do some relatively hard cutting, some sods with a few knives, and I was interested in doing it for a number of reasons. Primarily, a few of the knives were having issues with sharpening and edge retention, in particular on cardboard, and I needed to remove some steel from them to ensure I wasn't actually seeing the effects of the weakened steel from overheating during the initial grinding or acid washes and stuff like that. So because I was going to remove metal anyway, I took the opportunity to do so in a bit more of an informative manner. Each of the knives cut 8 sections of sod out, big enough to fit those patio blocks in, and it was between 50 to 70 cuts per section, so somewhere around 500 or so cuts in total were done with each knife, and they were resharpened after every section. And I examined how they cut in terms of efficiency, force used, just comfort in hand, security, and as well how long it took to resharpen them on both a fine and coarse bench stone. And I'll run through the knives one by one. The first one was a small Puuko by Uddo. This originally had a normal single bevel grind that you find on Puukos. I flattened it completely to improve the cutting ability, efficiency of sharpening in general. This knife cut relatively well and handled relatively well as long as the cutting wasn't that difficult. It wasn't into rocky soil and such like that. The problem was when you got into very difficult work, it's just a relatively short handle, which means that you can't use full power grips on it. It's mainly for precision type cutting, which it does relatively well. The steel is very tough. Had no fractures, just wore and dented and sharpened the fastest out of all of the knives. And I'm going up stepwise, sort of in carbide volume. The next knife was the AK-47 from Cold Steel. I've worked extensively on the handle to smooth out many of the hot points on the handle. It's squarish in all number of reasons when you first get it, but with all of that done, with the edge angle lowered, this was the most functional knife for that work if you look at all the sort of properties rolled together. In terms of, it had a very nice blade width to pry up the sods when they got stuck, relatively strong point, easily dug up some of the rocks. Steel was tough enough so it didn't fracture very easily. Grindability was high enough that it sharpened relatively fast. Very nice choice. Again, takes some work on the handle. Spyderco Temperance had a number of drawbacks. It's relatively heavy. It's a bit too long in the blade. You're not going to cut that deep, so you're getting to leverage disadvantages with the tip. And the carbide volume is high enough that you start to see fractures, and the grindability is low enough that you start to see a significant increase in sharpening times. This knife from SureFire had a couple of interesting attributes. It took damage the most readily out of all of the knives, but there's something very weird going on with this steel, and it's some combination of either overheating by SureFire and or it was given an acid wash, because the durability on this and the edge retention on cardboard is among the lowest I've seen of knives in this class. It even dents on relatively soft wood, like just cutting alder, which is even softer than pine. The overall function of the knife was relatively good, very similar to the AK-47, and even sort of more superior in terms of handle ergonomics for the short term, but long term all the holy parts of the grip sort of get to you. And I wouldn't want to cut more than a couple of them in succession because it would be a bit of a problem. Interestingly enough, you can see that it has almost no secondary edge bevel. Because I was doing a lot of work with this to try to see if I could resolve the edge retention and sharpness issues, I ground it down to a 0 to increase sharpening time to speed up some of the testing I was doing. As a consequence of this, this actually sharpens similar to the UddoPuuko, even though it's S30V, which has relatively low grindability. And that just shows you the effect that the width of the edge bevel itself can make a dramatic difference. So if you have very high carbide steels and you want to enhance the ease of sharpening, make sure your bevel width is minimized. This is the 710 from Benchmade. Nice blade length. Again, nice handle for ergonomics and security. A little bit too wide, so there's some issues in prying because it will tend to break the sods. Grindability on the M4 is very low, so sharpening time is very high. Biggest issue with this though is it was completely non-functional because the pivot screw, and in fact all the other screws, don't set well into the handle or the liners, so they back out and become very loose. Even after about 50 cuts, they become that loose that the lock is actually compromised and it actually collapsed in one of the cuts. So you actually have to use thread lockers on this knife to actually make it stable in the cutting. Last was a relatively extreme example of a steel. This is a custom from Mike Gavko in S125V. An extremely high carbide, very hard steel. Very comfortable in hand. Mike does really nice work, even though his handle shapes might look and are a bit funky. They're very well rounded, very contoured, and even this index finger choil can be put straight into the hand and there's no discomfort because again it's well rounded. So it indexes in your hand, it provides some level of security and knowledge about precision, but doesn't severely limit grips. This steel fractured again as you would expect on the harder contacts, and the very low grindability means the sharpening time was very high. And the other thing is, note how it comes to a very sharp point. This point ends up being one of the focus points for the cutting in comparison to, say, on the AK-47, where most of the cutting is done in the actually belly region right here. You can see that the custom from Mike doesn't have that sort of pronounced belly. It has more of a leading sort of tip, which means the wear will actually get concentrated on this, and because it's a very small point, as it's actually being a tip, it actually wears down very fast. So I actually see this little bullnose point that's actually here. I actually had to recut that twice because of the material actually being ground off. This was one of the nicer blades they used. You can see it's relatively wide at the base but relatively thin at the tip, so it's very flexible in use. You can easily get the thin tip in to make precision cuts, but when you want to do prying, you got the very wide blade down there that you can lift up the sods with without tearing them. Very comfortable, very secure, very ergonomic in hand, and relatively light. And you can see how you can go from really high power grips to precision grips, and they work relatively well. The only downside again is the very low grindability means the sharpening times are extremely high, so it wouldn't be the knife that I would pick for this because you're going to spend a lot of time sharpening it. Now the other thing that I should mention, I was using a relatively cheap bench stone to sort of amplify the differences in sharpening. If you use higher quality abrasive, if you use more coarse abrasive, then it drastically cuts down on sharpening time. So if I wasn't doing this sort of as an evaluation comparison, I was actually doing it functionally, and I was using Mike's knife, I'd simply use, say, an extra coarse diamond stone to reset the edge, and that would have brought the time required to sharpening down significantly. But interesting sort of experiment to do, and overall it sort of again reinforces the point that depending on what you're doing in regards to edge retention and especially ease of maintaining and creating the sharpness, high carbide steels are not always the best choice. Now, of course, this is an rather extreme example of cutting, because you're cutting through sods, dirt. There was contracts with glass, nails, bottle caps. So that's not really a commonly or frequent occurrence. But in general, the same effect is seen, not as extreme, when you cut used materials which are a bit dirty, such as ropes, cardboards, and especially materials which tend to have inclusions in them and can be quite demanding on the edge, such as forceful cuts through plywoods and other laminated materials, which can be very dirty because of the glues that they use, and again, it's a waste or chip product. It's very unlikely that high carbide steels are going to be the best choice in general, because you're going to get a lot of wear by fracture unless you make the angles that high that you compromise the cutting ability. So it was a rather interesting little experiment.